Students were analysing how many Smarties come in a 180 gram pack. Results were as follows. Find A, mean and standard deviation, B, 5-number summary and IQR, the interquartile range, C, draw a stem plot, D, draw a box plot, E, what does it say about the manufacturer's quality control? If they claim a standard 180 gram pack has 10 servings, where one serve equals 15 Smarties. So firstly, for standard deviation, we set up a table as shown. X is the variable values, and we put them in consecutive order, starting from lowest to highest this way. X bar, that's the mean. So for each one of these values, we need to work out the mean first, and then we need to subtract the mean from each one of these values and put the number there. So the first thing we do for the mean is we add up all these values, and that adds up to 2,378. Now we work out the number of samples, so let's just add up how many numbers there are, and we get 16, so n equals 16, so 16 packets were counted. And the mean x bar is equal to the sum of x divided by n, the number of samples. So that equals 2,378 divided by 16. And so x bar is equal to 148.625 average Smarties per packet. So now we go ahead and do this column. So 101 minus x bar, 148.625, is negative 47.625. Then we get negative 10.625, negative 8.625, negative 6.625, negative 1.625, negative 0.625, 0.375, 1.375, and the next one is the same because they're both the same number, 3.375, 4.375, 6.375, 10.375, 12.375, 13.375, and 22.375. And when you add all these up, you'll get 0. Okay, so now we're going ahead and squaring these numbers. So we've got 2268.14, 112.89, 74.39, 48.89, 2.64, 0.39, 0.14, 1.89, and that one's the same, 1.89, 11.39, 19.14, 40.64, 115.56, 153.14, 178.89, 500.64. Gives a total, when you add them all up, to 3,530.66. So the formula for standard deviation is S equals the square root of the sum of x minus x bar squared, which is this value here, divided by n minus 1. So S is equal to the square root of 3,530.66. Now there's 16 samples, so n minus 1 is 15. So S equals the square root of 235.377. Leave it in your calculator so there's no round off errors. And that equals 15.34. Okay, let's go ahead and set up the stem and leaf plot because it's easier to work out the 5-number summary from that. So there's no numbers less than 100 and 171 is your highest. So we're going to number 10 to 17 in sequential order here for the stem. So we've got 101, we've got 138, 140, 142, 147, 148, 149, 150, 150, 152, 153, 155, 159. And we've got 161, 162, and 171. So note that's an ordered stem and leaf plot. You need to make sure it's ordered to work out your 5-number summary. So firstly, let's find the minimum. So the minimum is the lowest number, which is 101. Maximum, that is the highest number, which is 171. Right, let's find the median. Okay, so n equals 16. If it was an odd number, if it was n equals 15, for instance, we'd be looking at the n plus 1 on tooth position as your median, which would be 8. 15 plus 1 is 16 on 2 is 8. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 150 would be your median. If the sample size was n equals 15 or an odd sample size, that is the relationship that you want. But in this case, we have n equals 16, which is an even number. So what we need to do is take the average of the n on tooth position and the n on 2 plus 1th position. So n on 2 is 8. So 1, 2, 3, 4, 5, 6, 7, this number, 150. And n on 2 plus 1 is 16 on 2 is 8 plus 1 is 9. That's 150 as well. So the median in this case, median equals 150. Now, just to show you how to understand it, if you don't know, if you can't remember how to apply these rules, what you can do is you can just cancel the first number and the last number, then the next 2 numbers in consecutive order, counting down from this position and up from this position. And then just keep going until you've got either 1 number left if it's an odd, or in this case 2 numbers left because it's an even, and you average those. So to work out Q1 and Q3, the first quartile and the third quartile, we're working out splitting it into 2 groups from the median position. If it's an odd number, you just ignore the median, you just cancel it, you don't use it in your group. So that's one group. And that's another group. Now for each of these groups, we find the median of those groups, which will give us the Q1 value in this group and the Q3 value in this group. So using that same procedure, we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers, and it's even. So we're looking for the n on tooth position, which is the 4th, and the 5th position for the first group. So 1, 2, 3, 4, and 5. So it's these 2 numbers. So we're looking at Q1 is equal to 142 plus 147 divided by 2. And that equals 144.5 Smarties. Now working with this next group, same deal again, we're looking for the n on tooth, so the 4th and the 5th position, because there's 8 data sets in the second group. So it's 1, 2, 3, 4, and 5. So you can see again, if you do it the manual way, you can cancel them out. You're left with two numbers that you have to take the mean from. So Q3 is equal to 155 plus 159. Don't forget this is your value that you start with, 150, divided by 2, and that equals 157. So we can find the interquartile range, which is equal to Q3 minus Q1, which equals 12.5. So the 5-number summary is written as follows. Min equals 101, Q1 equals 144.5, M equals 150, Q3 equals 157, and I don't have any room, but here I would put max equals 171. So in that order, and then we just say Smarties and put it in brackets. Okay, so now before we do a box plot, we need to work out if we've got any outliers. So outliers, we've got our Q1, Q2 positions. Now any numbers that lie past 1.5 IQ are lower than the Q1 position. So out here, any numbers out in this range or past this range are considered outliers. Any numbers less than Q1, which is 144.5 minus 1.5 times IQR, which is 12.5, equals 125.75. They call that the lower fence. And the upper fence is any numbers larger than Q3, 157, plus 1.5 times 12.5, the interquartile range, which is 175.75. So in this case, we look at the data. 171 is the highest and it's less than the upper fence, so that it's not considered an outlier at this stage. But 101 is, because it's less than 125. The next smallest number is 138. It's fine. So drawing in our box plot, we start with Q1 is 144.5, which is roughly here. Then we've got the Q3, 157, which is roughly here. And then the median, which is 150, which is here. And we close off the box. Then we draw whisker on the right. 171 is not an outlier, so it can go, the whisker ends at 171 on the right side. And let's put in our outlier, which is 101. And the whisker, because we've got an outlier on that side, the whisker on the left is going to go to the 1.5 times IQR position, which we worked out the lower fence position to be 125.75. So that's your box plot with outliers. Now finally, they've asked you to talk about the results and about the company's quality control. Now, as you can see, the median is slightly to the left, so it's only slightly skewed, positively skewed. And this can be seen by the shape of the stem plot, provided you forget the outlier. But you'd probably actually say it's only slightly positively skewed, and if anything, it's more likely symmetric. So the median is 150, which is in line with how many they claim is in a packet, because they've said that there's 10 serves and there's 15 Smarties in a serve. Now the range is 12 Smarties, Given that there's 150 in a packet, the percentage is not massively high. However, given that they're a manufacturing company with quality control and precise instruments, 6 Smarties is not a really precise quality, and I think they should probably look into their calibration of their instruments. Not a massive concern, but it is something that they could improve on.